Hello and welcome to this lecture on inheritance in Java. Classes in applications generally are related with each other. In a lot of occasions, you might see that, okay, there is already a class that I wanted to create, but I need some changes and some additions and so on. When you identify such a scenario, you need to go and apply inheritance. Because inheritance major motive is to reuse the code. So at the end of this video session, you should be able to understand how to apply inheritance in Java, understand the memory allocation when inheritance is involved, and understand the use of super keyword. Inheritance describes a relationship between two classes such that one class is merely an extension of another one. Now, extension may happen because you wanted to modify some of the features or add some additional features. Now, this does not affect the base class. The idea here is to reuse the code. Now, this is not the only way of reusing code. Now, there is always a good practice to say that prefer composition over inheritance. So, if the relationship is not really an extension of one class, then you should go for composition as well. Let's say, what are the types of inheritances? Now, inheritance can be divided into many different types. Number one is single. Number two is multiple. For certain reasons, it's not allowed in Java. There is also a multi-level inheritance where the inheritance is flowing from one base class to a subclass. The subclass acts like a superclass and flows that inheritance downwards. Consider a class B. Now, every class in Java automatically inherits from java.lang.object. But if you say class B is an extension of class A, then you're actually disconnecting the relationship of class B with the object class, because now there is a different base class or superclass. However, since every class inherits from java.lang.object, class A also inherits from java.lang.object. So because of which, automatically the features of java.lang.object are inherited to A, and through that it is inherited to class B. Now, members of java.lang.object are always inherited to any of them either directly or through multi-level inheritance. Use the keyword extends to achieve inheritance in Java. So syntactically, simply say class subclass extends superclass. Automatically the features are inherited to subclass. Now, a UML representation of a product class and a television, where television inherits from product, can be represented like this. We have a product class with ID, name and price with lot of getters and setters and constructors, and we have a television class that has two member variables, screen type and a dimension. Now note the arrow is always moving from a derived class or a subclass towards a superclass. Now do not change or do not interchange the arrow. The arrow indicates which is a superclass, which is a subclass. For example, the class product has ID, name and price. And on the other hand, class television is an extension of product. So we use the keyword extends, and then automatically the member variables, the getter setters, any other included members in the product class are automatically inherited to the television. So when you allocate memory for a television object, it requires memory for storing the data members of television, that is screen type and dimension. It also requires memory for member variables of the superclass, which is ID, name and price. So pictorially, it looks like this. So TV is a reference variable pointing to an object, and if you look at that object, there is a space allocation for members of the superclass, ID, name and price, and there is an allocation for screen type and dimension. Now, once you have this superclass subclass relationship, using a subclass object, how would we like to access the superclass variables? Now, since the data members of the product class are private, they cannot be accessed from inside the television class directly. For example, if you try to access the members like this, so we have a print function where we are trying to print the name and price, while name and price are inherited member variables. They are not the member variables of television, like the screen type. So there is absolutely no problem in accessing screen type because it is defined inside the television class itself, even though it is private. However, name and price are private member variables of the product class. You cannot directly use them. Now, the solution to this comes in the form of calling the getter of name and getter of price. So you call get name. Now get name is not available in the current class. It goes to the inherited class or the super class. There it finds. Now if get name is not public or protected, then there is a problem too. But generally getters and setters are public. So there is no problem here. Now you can also use a super keyword at some places. For example, method F1 in a superclass is overridden in the subclass. An object of the subclass has two definitions for the same method F1. But if you invoke the method of F1 using a reference of a subclass, Java tends to prefer the one that is overridden, that is coming from the subclass. Let's take an example. Here is a class product with print function. Now the print function is printing name and price. And here is a class television that extends product, and also there is a print function. Now our requirement is to print the data members of the product. Now if we want to do, we can put again system.out.println here also to print get name and get price. But the idea of inheritance is code reusability. Now we really don't want to repeat the code that is already available in the superclass. But if I just say, instead of doing everything on my own here, if I simply call the print function like this, this becomes a recursive call because always the control goes back to the locally available function. Now this way your code gets into an infinite loop and eventually your JVM will quit by saying stack overflow error. Now this is where we have to now say, hey, do not call my own function. Let us call the one that is coming from the superclass. And how do we do that? It's very simple. Use the super keyword, which is a reference to all the members of the superclass. So now we say super.print, and that calls the function from the superclass. And this way we have resolved the naming problems or the overridden functions problems. Let's quickly summarize what we have seen in inheritance in Java. Now, the extends keyword is the way through which you define inheritance in Java. So class A extends class B, A is the subclass, B is the superclass. Memory required by an object of subclass is equal to the total memory required by members of the same class as well as members of the superclass in the hierarchy. The keyword super also can be used sometimes to defer the function calls from own class to the superclass members. So if there is a name conflict, you should go with the super.